So this was a 7-mark question taken from one of the AQA level papers. So it says the concentration of hydrogen peroxide can be determined by titration with acidified potassium manganate. A 5 centimeter cube sample of the peroxide is added to a volumetric flask and made up to 250. 25 of this is titrated with potassium manganate. The titer is 24.35 and its concentration is 0.0187. First thing it wants us to do is write an equation for the reaction between acidified potassium manganate and hydrogen peroxide. So before I go any further, I'm going to write the overall ionic equation. Now the half equations for this were given in the previous part of the question, and the manganate one is a kind of a really popular one to know anyway. So let's begin. So we have MnO4 minus plus 8H plus 5E goes to Mn2 plus 4H2O. So that's the oxidizing agent, and the oxidizing agent is always reduced. And then we're told in the question that the peroxide is oxidized. So just underlining that bit there to form oxygen gas. So this equation is going to be H2O2 goes to oxygen gas plus electrons as it's been oxidized plus H plus. So to balance that, I need to put a 2 in front of the H plus and a 2 in front of the electrons. So the manganate is oxidizing the peroxide to form oxygen gas, and the manganate is reduced in the process to Mn2 plus. So the overall equation we have, well, before we can do it, we've got to balance the half equations. So you can see in the top half equation, we have 5 electrons, and in the peroxide one, we only have 2 electrons. So we've got to make the electrons the same in both half equation before we can combine them together, because we want the electrons to cancel on the left-hand side of the equation and the right-hand side. So if I use a different color to show this, so this one I'm going to multiply by 2, and this one I'm going to multiply by 5, because by doing that, the electrons become 10 and they will cancel on the left and the right. So if I just jump straight to the answer, we have 2 MnO4 minus plus 16H plus 10E minus plus 5H2O2. So what I've done there is literally added everything on the left-hand side of the two half equations with the multiplying numbers in for the electrons, goes to 2 Mn2 plus 8 H2O plus 5 O2 plus 10 H plus. Now the next thing to do is to cancel out things that are common to the left and the right hand side of the equation to simplify it down. So you can see that I have 16H plus on the left and 10 on the right, so therefore I can cancel that with that to leave me with 6H plus. I have 10 electrons there, and just realized I need to put the 10 electrons in on this side because of that being times by 5. Doing that causes these electrons to cancel. Then the next thing to do is to look if I've got anything left that can be cancelled, and if you look on the left hand side, there's nothing there. That is the same as anything on the right hand side. So now I just need to add everything together and then check to see that it's correct. So what have we got left? We have 2 MnO4 minus plus 6H plus 5H2O2 goes to 2 Mn2 plus 8H2O plus 5O2. So if you do a quick check, got 2 Mn on the left and the right. We've got 5 times 2 plus 6 is 16 hydrogens on the left, and 8 times 2 is 16 on the right. And then oxygens, we've got 5 times 2 is 10 plus 8 is 18. On the right hand side, we've got 10 plus 8 is 18. So that is correct. Finally, really important to check this, make sure the charge is balanced on the left and the right. So on the left hand side, we have 2 times plus 2 is plus 4. And then on the right hand side, we have 2 times minus 1 is minus 2. 6 times plus 1 is plus 6. So -2 plus 6 is +4 on the right. So therefore the charges are balanced left and right. Next, we're going to go through the question and underline the key information in order to work this out. And I will be using the template that I explained in the back titration video that I've made. So please go back and look at that, because I'm going to be using that exactly to answer this. So I can see that a 5 centimeter cube sample of the peroxide is made up to 250. And that 250 is the standard solution. 25 of that is then titrated against the manganate, of which 24.35 is needed, and it's got a concentration of 0.0187. In the template, I said there is always a starting sample, which we label as number 1. So the sample in this case is the peroxide, number 1. It reacts with something in the burette, usually an alkali, usually an oxidizing agent. In this case, it's an oxidizing agent, and we label that number 2. So the manganate is number 2. And I explained that 1 plus 2 react together to make a redox reaction, which takes place in the conical flask. And that reaction is the one that we've just written out. In the template, if I just do a quick drawing of it here, the sample starts there, it's into a standard solution there, then it goes to the conical flask, and there's the burette. And I said that we work backwards from the burette to the beginning to work out the, in this case, concentration of the hydrogen peroxide. Okay. First thing I need to do is work out the moles of the potassium manganate. So just to show, this is the end, this is the start. Again, look at the template that I explained in the back titration video, and we're going to work back to that sample. Number 1, moles of the potassium manganate is going to be C times V. Concentration is 0.0187 times the volume. Don't forget the volume has to be in decimeter cubed. So that's 0.02435. Obviously you're going to need your calculator. So let's work this out. Gives us 4.55 times 10 to the -4 moles of the manganate. So that's the number of moles of manganate that is reacted in the burette with the peroxide. So the next thing I need to do is work out the moles of peroxide. Moles of peroxide are found by the molar ratio, and you can see the molar ratio between the manganate and the peroxide is, underlined in green, it's 2 to 5. So therefore, to get the moles of peroxide, I need to divide the moles of manganate by 2 and then times it by 5. Therefore, H2O2 moles is 1.1336 times 10 to the -3. So that is the moles of peroxide in 25 centimeter cubed. But remember, it's come from a sample of 250. So the next thing to do is to work out the moles of it in the standard solution. So moles of H2O2 in standard solution. So just times it by 10, because 250 divide 25 is 10, gives me 0.011336. So that's the moles of the peroxide in the standard solution. Right, now let's revisit the beginning part of the question. It says a 5 centimeter cubed sample of the hydrogen peroxide was added to a volumetric flask made up to 250. We've got the moles because if I just add like a little test tube there, right, just put in, so that's the original peroxide, right? So that is your sample. So that's that bit. And all that's happened at the beginning is that is dumped into this volumetric flask and distilled water is added in on top. So the moles hasn't changed. Once you know the moles in that standard solution, that is the same as what it was in the original 5 centimeter cube sample. That answer there that I've just worked out, 0.0133836, that is the moles in the standard solution, which is also the moles in the original sample. However, the concentration is going to be different because you can see there that the volume is much, much smaller. It's 5 centimeter cubed. Let's go ahead and work that out. So step number 4, H2O2 original concentration. So therefore C equals moles over V. Our moles we just had there, 0.0113836 divided by the volume. Now the volume this time is 5 centimeter cubed. So that in decimeter cubed would be 0.005. So if I divide that, the final answer comes out to be 2 decimal place, 2.28 moles per dm cubed. And that is the final answer. Thank you for watching. If you found today's video useful, please like and subscribe and comment down below if there's any topics you would like me to cover. Also, if you need help with exam technique in chemistry, check out the links below the video.